Please welcome Chris Anderson.
Thank you, Andy. Thank you also for this, for everything you've done, for the opportunity to stay at the Ace Hotel for the first time. I made the mistake of ordering a light beer at the bar. I won't do that again. Andy asked me to tell my own story here. A year ago, I was an editor of Wired, a writer, and today I run a Tijuana drone factory. Sort of let that settle there, Tijuana drone factory. And I'm finding myself in agricultural robotics and maybe building a 21st century aerospace company, and this was kind of totally by accident. I just kind of wanted to tell the story of how that happened and what this model of everything that Andy talked about, the crowd, openness, being willing to make mistakes in public, allowed a bunch of people to do and where we think it might go. It started for me with, I have 5 children. And 2006, trying to get my kids interested in science and technology. And this is like my reoccurring weekend thing, is to try to find a project to do with the kids that'll get them interested in the stuff that I love. So I started a whole site called Geek Dad, which was entirely about projects designed to be fun for kids and fun for grown-ups that teach science and technology. And not only, the site is a great success in the hands of other people, but not only did it not work with my kids, but now anytime I try to do a project with my kids, they ask me, are you gonna be posting that on Geek Dad? They won't even let me take pictures of our projects anymore. So it's a complete failure, but there was this one weekend in 2006 where these 2 boxes arrived in the office at Wired, and I thought, this is gonna be the weekend that we crack the whole, inspire our kids. One box was the beta of the new Lego Mindstorms robotics kit, and the other was this radio control airplane. And I thought, Saturday we're gonna build a robot, and Sunday we're gonna fly a plane. What could go wrong? So this is what went wrong. We built the robot, and this is my daughter Erin, and the first project you do with Lego Mindstorms is to build a tribot, which you assemble, follow the instructions, then you program. And at the end of the process, you press go, and it rolls up to a wall and then backs away. And my kids just stood there, and they said, you've got to be kidding. We've seen Transformers, right? Where are the frickin' lasers? And I realized suddenly that it is impossible to compete with Hollywood with robotics. It's impossible to compete with computer graphics with real technology. Real robotics is hard, and it takes forever to get it to do anything. So that didn't work well. And so the next thing we did is we took an airplane to the field, and we watched YouTube videos of people doing acrobatics, and I got them outside, which was hard enough, and then got them to the field, and I threw the plane, and it went straight into a tree. And if that wasn't humiliating enough, I got and climbed the tree to retrieve it. And just as they sat there, there's that mortifying sight of their father climbing a tree to recover a model airplane. And they just cemented everything they suspected about science and technology projects that their dad tries to do with them, which is that they always end with failure, they're always boring, and it's just that thing that dad wants to do. So I had to bribe them with lots of ice cream. So I came back, and I was really kind of annoyed with myself, and I was annoyed with them, and I was thinking, how could that have gone better? How could we have come up with a cooler robot and a better flying plane? And I was thinking about the plastic bits that came in the Lego Mindstorms, and it came with, it came with these sensors, these gyroscope sensors and accelerometers and a compass sensor and an ARM processor, and I thought, I don't know anything about robotics or airplanes, but I think you could almost fly a plane with this. So I Google autopilot, and there's this math, and then I got vague sense that you sort of had to put the sensors together and kind of, merge their inputs, and so I dragged the little sort of, bits of, you know, the little program code bits around, got the kids to do it, and then here it is, the world's first Lego autopilot that my kids and I did on the dining room table that night, and then we put it in a plane, and unbelievably, it almost flew. But came so close to almost flying that I was like, I got chills. By the way, this is the world's, we eventually got it to fly autonomously, and it's the world's first Lego unmanned aerial vehicle, which is in the Lego Museum in Billund, Denmark, which I was incredibly proud of, but then the representative from the US government got in touch and said, you do realize that autopilots are regulated as munitions, as essentially cruise missile controllers, and the export of military technology is in fact a violation of the ITAR protocols, so you've weaponized Lego. I was really hoping they would call us up for a congressional hearing. I could get the 9-year-old to explain. But sadly, it didn't happen. They didn't prosecute me. My children, as I say, lost interest instantaneously and went back to video games, but I had chills. I was like, you know, there's been like 4 times in my life when like the world rocked underneath me, and I was like, everything is different now. I mean, the first time I tried the internet, you know, and I was in the science world in 1993, and I used NCSA Mosaic, and I was like, everything's different. Then I went to China in 97, and I was like, everything's different. Then there was, sadly, September 11th. And then there was that moment at the dining room table where I Googled autopilot and built a drone out of plastic bits on the dining room table with my children. And I didn't know what was different, but I knew something radical had changed in this world. And I went on a mission to find out what that was. I could have, you know, done a deep dive in research, but instead I decided to be stupid in public. And so I created a website called DIY Drones, primarily so that I could ask stupid questions on the hopes that someone would answer them. And it turns out that they did answer my questions, but also the more important thing is that it liberated other people to ask their own stupid questions. And this was a moment where everybody was stupid about what was happening here. And the reason everybody was stupid about it is because turns out that the enabling technology, the catalytic technology was smartphone guts. It was the MEMS sensors and the ARM processors and the GPS and the cameras and the wireless and the batteries. All that stuff that's in your pocket right now was suddenly available to regular people at very cheap prices. You can buy the bits in Radio Shack now. And it was like that homebrew computing moment where, I don't know, what was it, the 8088 chip was suddenly available and that regular people could do things with it, and thus Jobs and Wozniak and the Apple II. But this was that moment for what ultimately would become robotics, wearables, the Internet of Things. All those bits were coming out. And some people saw it through Lego Mindstorms like I did. Some people saw it through the Wii controller. But a lot of cool companies suddenly emerged out of that spot where people sort of said, I don't know what's going on here, but this chip is extraordinary. And the problem is because it's so interdisciplinary that nobody knew everything. There was analog electronics and digital and software and artificial intelligence and wireless and the aerodynamics, and everybody was ignorant about some element of this. But we were all empowered to do something about it because these technologies were available. They were cheap and easy and open to everybody. And so people came on this website and they started designing drones. And it was really cool, and we were trading Eagle files and, you know, and code, and it was incredibly exciting. We felt like we were really kind of, you know, beating the aerospace industry and sharing the designs. And then the next generation of people came on and they said, this is fantastic that you're doing this. However, I really don't know when you say, here's the link to the Eagle file, and here's a link to where you can have the PCB fabbed and where you can get the components from DigiKey, and here's how to surface mount, you know, solder surface mount components with a microscope. They're like, could you just do that for me, please? Could you just like have a company and sell it? So I was like, okay. I met this guy named Jordi Munoz on the internet on the website, and Jordi seemed really smart, and so I said, tell you what, you make the boards and my children will pack them up in bags in our dining room table. And this worked fine. And then Jordi kept sending me these pictures. He says, I've moved out of my garage, I've got a little industrial space. And I was kind of impressed by the space. I was actually more impressed by the shelves, that he had shelves, which is really professional. There was also, behind the shelves, there was a pick-and-place machine that he bought on eBay, used one, and downloaded the manual from Google. And then the woman on the far right is named Rebecca, and she's a bookkeeper. And I didn't even know what a bookkeeper was, and we had one, apparently. Around this time, I realized that this guy I'd met on the internet was this 20-year-old guy who just graduated from high school in Tijuana. And I didn't know that when we first met, and I didn't think anything about it. I essentially thought he was going to be soldering circuit boards, but he turned out to be this genius who represented these two wonderful things about his generation, which is he doesn't know what he doesn't know. He didn't know that regular people aren't supposed to build factories, and he's completely fearless about trying. And so he kept sending these pictures, and there was the next picture. This one was actually published in Wired. He's got these new pick-and-place machines and stencil printers and reflow ovens and CNCs, and he's got his staff. And then he opens this like clean room, electronics manufacturing area in Tijuana, and then here's where it is now, and this is all on credit cards, and cash flow, and they just did it. And it was right around there, maybe in 2012, that I was like, okay, I don't know how I found this guy or how he found me, but I'm gonna quit my job. It's amazing. We're on to something, let's just do it. So I quit my job and took over the company, and then we're like, okay, we're making drones, we're using open source hardware and software and community and everything that we've talked about so much, and then people said what they're for. I mean, why would anyone want a drone? And we weren't quite sure. This is what they look like today. Here's one of our early prototypes. They look like science experiments, and it's pretty reasonable to ask, okay, it's cool that it flies by itself autonomously, controlled by a smartphone, but why would anyone want one? And we kept saying, well, I'll bet they asked Jobs and Wozniak that too, and I'm sure their answer was, because you can program it, and then they put it in the hands of regular people, and then regular people figured out what computers were for. And I kept saying, if you like the PC, you're gonna love drones. But I didn't really have a good answer. But I did know that making them cheap and easy and available to everybody and demilitarizing them and taking them out of the military-industrial complex and putting them on the hands of regular people was the route to the right answer. Eventually people told me, well, this is what an autopilot looks like, this is what we make, these boxes, and you put them in, you just click a button, and they make any one of these kind of vehicles fully autonomous and robotic. And this is the software, and we sort of said, well, maybe you don't need to fly things, maybe you should just click on maps, and then you just, increase these waypoints, and then it imagines what the camera would see, and then creates these paths automatically so that it maps things. And it's like, okay, mapping, that could be interesting. Cheaper, easy, anywhere, anytime, access to the sky, free aerial data, low, high resolution, et cetera. That could be cool, competes with satellites, manned aircraft, et cetera. I still didn't really know why anybody would want one. In the meantime, I decided, well, the reason we don't know why anyone wants them is that they're too hard to use, so let's use autonomy what it's good for, which is to take it away from the whole piloting experience, and just now we use these tablets, and by the way, if you're wondering whether you're gonna see one, now we use these tablets and we just sort of fly with phones and such. After this talk, we'll go outside and we'll do it over the, there's a grassy area across the way, which looks perfect, except for the baby goats problem. So baby goats, drones, I think this will work out okay. Anyway, so we thought, well, we'll make it easier. We'll go from like the Apple II to the Mac version, which we have, which is just a touch interface, it's very intuitive. We still weren't quite sure what people would do with it. And then these farmers got in touch, and they said, you know what we're using it for? We're flying over fields, and we're gathering data about crops, and this is actually really important for what's called precision agriculture. I'd never stepped foot on a farm before. And then these farmers are saying, this is what we've been waiting for. It's big data for the biggest industry in the world. There's a movie that came out a couple years ago called Looper. Anyone seen Looper? Loopers? It's really cool. Maybe you remember this scene. Does anyone remember this scene from the movie? This is a farm. This woman walks past this bit of agricultural equipment, this farm equipment. the camera pans, and this farm equipment just sort of flies over the crop and does its thing. And like, it's not even part of the story. It's just one of these little moments that goes by. And it's just like, it's so banal, it's so pedestrian, it's a beat up bit of farm equipment, but it just happens to be a crop spraying drone. And that's a science fiction story. And I thought, wow, we could do that like right now. So we were up in Berkeley, and so we were quite near Napa Valley, so we sent our flight ops teams up there, and this is sort of what we do now. This is what the view from the drone. And this is a vineyard out near Napa. Grapes are high-value crops. Turns out it's really important to know things like how the water is distributed, when the grapes are ready, the density, the different kinds of grapes, the soil, etc. These are the kind of views that you can't actually see from the ground, but you can see from the air. This is what's called a multicopter with a stabilized gimbal. This is a video, but it's also taking pictures in real time with a still camera facing down, which you stitch together. But on any given weekend, there's drones now buzzing over vineyards in Napa, and we're not sure exactly how it's going to change agriculture, but we know we can do it. So I ended up learning more about agriculture, and I spent more time with vineyards, and I found these roses here. Maybe everybody knows why there's a rose at the end of a row of grapes. Does everyone know this? Because I didn't know this. Nobody knows this. So it is either a 2,000-year-old data sensor for grapes, or it's an old wives' tale. No one actually knows whether it works or not, but the theory is that roses are susceptible to the same fungal infections as grapes, but that they show the effects sooner. It's like the canary in the coal mine. And so that if your rose is healthy, that's great. If your rose starts to wilt, then you've got a fungal infection that you can then spray with fungicide. But it's basically a 1 analog pixel per row sensor. And this is 2013. We have a data scarcity problem in the biggest industry in the world. And we can't just put sensors everywhere because of power and wireless and the fact that often the ground is turned over in the course of planting. So we need another way to get the sensors to the farm, and it turns out the best way is to just fly them there. So this turns out to be the big data, a big data market that has just been starved for big data. If you can get these aerial images of the shots of the farms in high resolution, anytime, anywhere, below the clouds, which the satellites can't do, free, it costs nothing to gather the data, then you can do what they call closing the loop. So rather than resorting to bad things to get food, which is to say monoculture, the reason we use these monoculture seeds and plant the same thing everywhere is because it's predictable. Why do we need predictable? Because we can't measure what's going on during the growing cycle. Why do we spray fungicides and pesticides and herbicides according to the calendar, June, July, rather than waiting until we have a disease outbreak? Because we don't know when we have a disease outbreak, and by the time you find out, it's too late. You've lost the whole crop. So we are drowning our earth and our plants with chemicals because we don't know better, because we don't have the data to be able to spray only when we need it and where we need it. That's an open loop problem. You push, but you don't know what the consequences are. And so we overdo it. We use too much water, too much chemicals. If we could only know what the consequences are of using this chemical or using that water, or when it needs it, on a really granular basis, we'd use less chemicals in our food and in our land, to say nothing of the water and the other inputs. Half of the inputs into farming are wasted because we have a data scarcity problem. So I now subscribe to Successful Farming magazine, which I highly recommend. Successful Farming magazine, and not to discount Farm Industry News, which is also good, although I'm a little, I think Successful Farming is sort of the Wired of agriculture, if you will. It's amazing. I mean, look, anytime you kind of, you sort of teleport into an industry you know nothing about, it's just like, oh my God, they have these terms of art and these threshers and harvesters, and it turns out that farming's totally robotic these days. These tractors, they drive themselves, they're GPS guided. The cabins of a tractor these days are really designed for designed as video projection booths because the farmers watch movies all day. Their job is not to drive the tractor. They're just there in case anything goes wrong. And so they're these like rolling entertainment centers. and they use satellite imagery. They've got increasing amount of sensors. Increasingly, they're using robots to actually pick, to harvest the vehicles. Robots milk cows. Sometimes robots actually encourage the cows to come into the milking shed, feed them, and milk them when the cow wants. Rather than when the farmer wants. The cows drive the robots. It's just unbelievable. And so this is like, it turns out that they know that they want robots and we have robots. So this is the opportunity that we stumbled upon. And so what we thought the experience is, and getting back to that looper moment, that rather than needing any expertise, that farmers just sort of pull up their smartphone, point at their field and say, map this. Or maybe it does it automatically like a sprinkler system. And then the software finds out that the tomatoes are ripe, or that they've got a leak, or that you've got a fungal infection, or that there's a planting problem, and it just sort of tells you what to do, and the farmers then farm better. And so as we go more into this, we realize that's just with cameras. What if you could see things that farmers can't see with their own eyes? And the next thing that the farmers told me is that there's something called normalized differential vegetation index, which is basically the difference. It reflects the properties of chlorophyll, which is that healthy chlorophyll absorbs the red and reflects the near infrared, whereas unhealthy chlorophyll reflects them both. And if you could only take two pictures, one the way your eyes see it, and the other way the way an insect eyes see it, with that near infrared, and compare the two, you could see unhealthy plants. You could see plants that are in trouble that you can't see with your bare eyes. And this is what it looks like. What we do is we take the cheapest 3D cameras. Remember 3D cameras, the ones with the two lenses? And it was a fad. But you can buy them really cheap now on eBay. And what you do is you take the top off the camera, and inside, regular cameras have an infrared filter. And that infrared filter is basically, we have like the worst eyes in the animal kingdom. Insects see way into the infrared, but we don't. And so the cameras have been sort of dumbed down so that the world looks like it looks to us. And they put this infrared filter to cut out the infrared. You go in there, it's a little bit of plastic, you take out the infrared filter and you put in a blue filter instead on one of the lenses. And now those 3D cameras are a visual spectrum, the normal spectrum and the near-infrared spectrum. They take the two pictures at the same time. You stick them through a Photoshop filter, basically, and you get this. The red is damaged chlorophyll, the green is healthy. And it tells the farmer things that they know, like, where they drive the tractors messes up the crops, but also things they don't know, like those little patches of unhealthy stuff. And this is like, for a farmer to suddenly see their crop in a spectrum that they've never had access to before is, sometimes it's mind-blowing, sometimes it's not helpful at all, but the only way to find out is to do it. And so right now, our biggest problem is that we have this technology, but farmers don't know what question to ask. And so we go to the farmer and we say, what do you want to know? And they're like, what can you do? And you're like, well, you tell us what you want and we'll do it. And we just have to show them data. We have to say, well, this is what your farm, it looks in stills, in super high resolution, in video, in near infrared, in long wave infrared, and eventually farmers say, that's interesting. I can work with that. I'll plant less, or I'll water more, or whatever. And this is a really interesting moment where we now have the ability to get the big data, but we now have to get the ability to ask the big questions. And this is what we're going to do over the next few years. We're just going to boots on the ground. We're going to tromp around in farms. We're going to put these things in the hands of farmers, the alpha farmers, if you will, and they're going to figure it out in the same way that we figured out how to use the PC, and then we figured out how to use the internet, and we figured out what the web was by filling it with our own ideas, our own creativity, and our own needs. We're going to try to put these things in the hands of regular people, and let's see what they do with it. So this is you take the images, you stitch them together, and you end up with these pictures that mean nothing to us, but maybe a huge amount to a farmer. I'll end with just this one picture, which is of a vineyard. And this tells me nothing, but a farmer looks at this picture and they see three things. They see this green strip in the middle, and they're like, oh, well, that's an ancient stream. That's the alluvial soil from an ancient stream. And what that means is what I thought was one field is actually two. There's the grapes over the slightly richer soil and the grapes over the other soil. Not good or bad, just different. And so what this farmer is thinking about doing is creating what's called a geofence. And the pickers would wear these smartphones with the GPS, and they'd have these two buckets. And when they're on the light soil, it would be green, and those grapes would go in this bucket. And when they cross the geofence line, which is established with this aerial imagery, it goes to blue, and they put the grapes in the other bucket. And now one grape field has become two grape fields, and they have two different kinds of wine. It's differentiated. Maybe one's better, maybe one's worse, but the point is they now have a granularity they never had before. So that turns into geofences, that turns into precision agriculture. Oh, and they said, oh, and by the way, see this little thing up there, that little dark spot? I've got an irrigation leak. Who knew? And that was just one picture. So that's what happened in 6 years. We went from playing with my children with Lego around the dining room table to the future of agriculture. We just did what we could do. We worked together as a community. Tens of thousands of people around the world did it because it was fun. We ended up building something extraordinary. We're only part of this movement. It's open. It's global. We have as many students, teenagers contributing as we do aerospace engineers. And if we get this right, we're going to do something the aerospace industry could have never done, which is find out what the future of aviation is, not by letting Boeing tell us, but instead by figuring it out ourselves. Thank you very much.